Let us look at proposition number 29 of book 11 of Euclid's Elements. The proposition says parallelepipedal solids which are on the same base and of same height and in which the ends of their edges which stand up are on the same straight lines equal one another. So let's see what this means. First of all, these two solids stand on the same base. So this is the base. Then one of the solids is this. This is one of the solids. Now the other solid is, so what the proposition is saying, that since these two solids are standing on the same base and they have the same height, that means they are equal to each other. And here when we say solids are equal, it means the volumes are equal. So let's take step by step of how to prove this. CB, where is CB? CB is equal to DH. Why? Because they are the opposite sides of the parallelogram CH. CB is equal to EK. Why? Because again, opposite sides of the parallelogram CK. Now, since CB is equal to DH and CB is equal to EK, it means that DH is equal to EK. Now, DH and EK, they have EH as common. So let's subtract that from both. We are left with DE and HK. Now, since DH is equal to EK and EH is common, so if we subtract EH from both the lengths, then we end up with DE is equal to HK. That means triangle DCE is equal to HBK. Why? We have already seen DE is equal to HK. Now DC is equal to HB, opposite sides of a parallelogram. Similarly, CE is equal to BK, opposite sides of a parallelogram. So using side proposition, we can say that these two triangles are congruent. Similarly, triangle FAG is congruent to triangle MLN. DF is equal to EG because they are between the same parallel lines. So that means parallelogram BG is equal to parallelogram HN because DE is equal to HK and FG is equal to MN. Parallelogram CF is equal to parallelogram BM, opposite faces of a parallelepipedal solid. Similarly, parallelogram CG is equal to parallelogram BN, again opposite faces of a parallelepipedal solid. So that means the prism contained in triangle AFG, triangle CDE, and the three parallelograms, that is AD, BG, and CG, is equal to the prism contained in triangle MLN, triangle HBK, and in the parallelograms BM, BN, and HN. Since these two prisms are equal to each other And this part of the solid, that is EHAL, that is common to both the parallelepipedal solids. So now we add this to the equal prisms. So which means solid CM is equal to solid CN. So we have shown that parallelepipedal solids which are on the same base and have the same height, and in which the ends of their sides which stand up are on the same straight lines, they are going to be equal to each other. So that was proposition number 29 of book 11 of Euclid's Elements. Again, let me remind you, there is a link to a PDF book which describes all these propositions in detail. Please feel free to download it, refer to it. And if you think somebody else can also benefit from it, please do share. That's it for now.